So tips and tricks for your service-oriented architecture. Who of you actually know what an SOA is? SOA, service-oriented architecture. Okay, that's perfect, one or two. That's good. The very first thing is that there is a huge warning for this talk. There's not going to be any cake PHP code at all. We're going to talk a little bit more abstract. We're going to talk about architectures. This talk is actually for those that are stuck with legacy code, okay? With applications that have been written like 5 years ago, 2 years ago, and that nowadays, if you compare the code that you would have written now, they suck. People who are dealing with clones. So how many of us do need to send emails, a lot of batch emails like with clones, or have like some heavy jobs that they have to run like at 4 a.m. in the morning, just because the servers else would be overloaded. For those who need a solid foundation for their product, so you're saying, I'm a startup, I'm going to build my own product. It's going to be huge if it goes well. So I need to build it the right way. I can't afford like to go out with like a very simple and crappy solution that I have to rewrite from scratch in like 6 months. For those who actually heavily rely on web services, REST, HTTP, plain old XML web services, whatever. For people who actually need to make two components interact. And for those who need a pluggable software architecture, for those who actually need to rewrite an entire part of their system, let's say notifications, let's say the SMS gateway, and need to do it in 1 or 2 days. All of this falls under SOA. And this is what we're going to talk about. The agenda, sorry for this ugly slide, but that's fine. So first we're going to see like what a service-oriented architecture is actually. Then a few tricks and tips that, that personally I've found out throughout my career. And then a conclusion. I will introduce myself at the end of the talk because I don't have that much time and there are a lot of things to talk about. So first of all, okay, so what? What is a service-oriented architecture? Basically, it's a design, okay, that fragments software components in different services, okay, to make the architecture pluggable. It doesn't sound like very simple or very smart, maybe. So, like a quick example would really clarify things. What you do is actually, okay, I'm going to start my service. It's a community website, whatever. We're going to have, yeah, it's a Miley Cyrus community, whatever. And because that's popular now, right? And that website, that service, okay, that website is one service, right? And it does everything. Let's say that it has a front and a back end, everything all together, right? So you start with a monolith, right? With a monolithic approach, you have one cube, and that's all you need right now. But then you might want to add like a chat, like your community grows, your community evolves, you know. At that point, you will say, okay, PHP might not be the best to do that. PHP actually sucks for doing that. So what you say, we add another layer. Okay, let's say a Java-based chat or whatever. So since you can't really do those things well with PHP, you just pick the right tool for the right job, right? And you add another component. So at this point, you have two services, your, let's call it website, and the chat system. At that point, what happens? Things are scaling like really, really well. You get a lot of page views and so on, but the front end does a lot of huge queries, whatever. The DB becomes a bottleneck, right? At that point, what you do, okay, you say, okay, I'm just going to use the DB for my backend, and I'm also going to persist data in like any kind of NoSQL storage system like Redis, like Memcache, like Couchbase, right? So that the front end can read the data directly from the storage system, which is way faster. So what you say, okay, the back end is going to stay there, and I'm going to have one front end that's just going to interact with this new storage. At that point, the thing is, in this way, you can scale really well, because the only thing you have to do is add more nodes, okay? So things are separate. You just add like a ton of new nodes. If you're familiar with Amazon, that also helps you saving costs, because let's say that your backend will do like a lot of funky stuff. It will need a lot of memory, okay? So you go for an high memory machine. Whereas the front end, it will have CPU bound operations, right? So you go for another machines. Amazon has the C3 machines, which are the so-called high CPU machines. That helps you save money, because else you would end up with a machine that needs to have a lot of memory and a lot of CPU. At that point, your main architect says, okay, we made a mistake. It's called Java. So, yeah, a lot of people did that, okay? So we want to replace it because it's really not maintainable. We don't have the know-how. I mean, Java is good. It's solid, but we can't deal with it. So I want to add something funky to the mix, right? Like Node.js, okay? Something new, something colorful. Something scary sometimes, right? Yeah, clowns are not funny. So then you say, okay, let's replace it. Let's throw something to the mix. I have replaced an entire part of my architecture without touching most of it, right? I just changed one service. That's it. Human understandable words. We split features into separate services. How these services communicate with web services, with messaging queues, and so on. That's it. It's not nothing like, it's not rocket science or so on. It's very, very simple. In the real world, what do we do usually in SOA? Well, first of all, data. A lot of things, like the first thing that I've been wondering as soon as I decided, okay, let's do this thing, is like, how should we deal with data? Because each service, should it access like the same DB, the same type of DB, or what? Well, actually, they can share the data, but they also might have their own data layer, right? So as we've seen, the front end might need something very fast, like Redis, whereas the backend might rely on something like MySQL. And the thing is, even the backend might rely on MySQL for some things, because it's ACID, right? So it's solid, it's well tested. If you have to process transactions, you go for it, right? But for other things, you might use whatever, a document DB like CouchDB or Mongo, or a GraphDB like OrientDB, or Neo4j. Okay, that's it. So the only thing is abstract the data. So you might think in terms of rows, but actually at the architectural level, you think in terms of entities. So it's not that I have an address with rows, but I have an entity address with attributes. That's it. And you don't even know, and you don't even care on how they are stored. Okay, because all of those services will have a different way to store the data. It might be that they share it, or it might be that they treat it differently, each on its own. Then web services. Of course, if you have to fetch data, create new stuff from a service to another one, right? You're going to use web services. It's like an easy way where we're talking about the web, so it's just an HTTP call, right? So what are we going to use? Well, if you have to immediately notify a service, then you're going to use a web service, right? And what it can do is like fetch data as well as post data or update entities. So, POX, do you know what this means? It's plain old XML. This shitload of stuff that you've seen here, okay? So basically, it's just like plain old XML without any structure, without any form, without any rule. I mean, it's just a way to serialize an object, right, basically? That's it. Or SOAP. SOAP is pretty cool. I have like mixed feelings about it because it has whistles. Have you ever, by chance, worked with SOAP? Okay. Basically what happens, SOAP has whistles that are basically the contract between the client and the server. They share a whistle, which is like the definition of the service. It says, I'm going to expect this field with this type of data inside it. It says, okay, you can't really make a mistake there because you know what you're going to send and what you're going to receive, right? You can use SOAP. You can use HTTP web services, which is what a lot of people call REST. And then you can use REST web services, or so-called hypermedia web services. Thing is, note to yourself, after this talk, let's see what is the difference between an HTTP web service and a REST web service. It's called HOS, which means hypermedia as the engine of application state. It's what distinguishes a very common HTTP API from an actual REST web service. And I would suggest you to go on Amazon and buy this book, because it's pretty cool. It explains like REST from A to the Z. and you will find like all of this, this unknown or less known things. And then events. We've been talking about data. We've been talking about how to exchange data, like with web services. And then we fall under the category of events. So what happens? It might be that you actually need to retrieve data, or if you're placing an order from your front end, you're going to post that order to like your backend, right? Or you might want to notify stuff. What does that mean? It actually means that there is no one actually listening to that call and just replying to you back on the fly. You're just going to send a message. You will notify the architecture that an event has happened. Okay, with a message queuing server like RabbitMQ. What it does, it lets you do asynchronous messaging queues, which means that right now the customer has registered, okay, but I have 1 zillion more customers that just signed up, right? So I can't just send the email right now because my email server is gonna, I can't say that. It's gonna not be happy about it, right? So I'm just gonna send an event to Rabbit. And it says, customer alex.nadalin@gmail.com just signed up. When you're fine, when you processed all the other customers, send him an email, okay? That's it. Second point of the presentation, the tips and tricks that, in my own experience, I have learned the hard way, just by having things down or like smashing my head against my desk. Avoid SOA. Yeah, why? It's a very cautious advice because it's difficult to test. Can you imagine? Right now, you're gonna just clone your repo of your application on GitHub. Everything is there. It's one application. It does everything. Okay, that's fine to test. But if you have to download like 3 or 4 repositories, or you might have everything in one repo. That's how we do it. But anyhow, if you have like 3 or 4 applications, you have to bootstrap them. You might have to install RabbitMQ, for example, or ZeroMQ, a messaging queuing server. It's not that straightforward, right, at the beginning. And it's complex, because you see, you add a lot of pieces into the mix, right? So SOA, I'm going to tell you this. It's overkill for most of like the cases that we might face in our career. Like, if I have to build my blog, fuck this, I'm not going to use it, right? Can I use that word? That's fine. Yeah. That's perfect. This is a community that I love. But the thing is, if you're handling like a very huge project or a product that needs to be done correctly from the very first day, and you know that it's going to scale, right? This added complexity will pay off on the long term. Free the data. And what does that mean? Consider eliminating foreign key constraints, because you actually might have the orders, okay, that are in one DB in one table, and actually the customer database, which is in another DB. So if you want to put a foreign key from the order to the customer, well, that won't work. You can still do some tricks with relational databases, but if you're using MySQL for one thing and OrientDB for another, for your customer DB, there's no way you're going to do that. So yeah, I mean, that's something that you have to consider. And then abstract it. I mean, as I said, you might think in terms of rows, but there's no such thing as row right now. We're talking about entities, or we're talking about entities of your domain model. Thing is, you don't have the ability for a few things to do joins or retrieve related data, right? As easily as you would have done that before, right? But the thing is, you're using the proper tools for what you need to. Your community, your customer DB, might want to actually be persisted on a graph DB, you know? Because with a graph DB, you can do traversal operations and analyze your graph of users. So you can trace interests, you can trace who of your users were like drinking at the same pub 2 days ago and stuff like that, which is something that with MySQL you would never be able to do on a large scale of data, okay? Because it simply doesn't perform well for that kind of operations. Relational storage systems are made for other stuff. Then standardize, and this is probably the most important thing that as a team leader or as a head of development or as simply as a good programmer you should follow. Build a very vast suite of end-to-end tests, integration tests, okay, and give it to your developers. So then, as soon as they clone the repo, as soon as they install everything, they're going to be able to like just test the architecture in its whole, right? Because the thing is, every developer will eventually need the entire architecture in its system, right? And that's kind of a hell to install if you have different components. That's why you would have to provide them with the tools to be able to actually install that in maybe less than an hour, 30 minutes. That's it. And you can't do that if you don't, for example, have standardized VMs and so on. Thing is, setting up VMs and so on is such an hassle, right? It's everyone wants to have his own environment. We're not very used to work with them. But the thing is, someone invented Vagrant, which it's perfect for this purpose. Sorry. So that just use that. How many of you are using Vagrant currently? Okay. Next year, all hands up. Like seriously. Then identify wisely. What does that mean? Authentication is king because you have users that perform operations on various services, right? But you want to like bring your user identity on all of those services so they don't have to log in twice or 7 times on each of those services because that wouldn't work. So you should centralize like the identity of your users, and that's a service on its own. The first rule of thumb is never handle credentials unclear, right? So always go, because the problem basically is always, to me, the biggest concern is if you have a man in the middle or whatever, those are gone. I mean, so just use HTTPS if you're working with the HTTP protocol, and tokenize. What does tokenize mean? Well, we can use OAuth, we can use OpenID, right? You know these two protocols, right? Or we can use JWS. What the heck is JWS? It's called JSON Web Signature, okay? It's a token, a JSON Web token. Web because it works on the HTTP protocol because it's pretty easy. It's JSON encoded, and it's simply a token. So what happens? You sign this token, maybe with a public key, maybe with a private key, and that makes the JSON Web Signature, the JWS that we were talking about. And all of this is part of a specification called Jose. I think it's the Mexican way, I don't know, man. It's JavaScript object signing and encryption. And I'm not joking, it's actually called Jose. I mean, if you look it up on the internet, it's Jose. So that's the link to the specification, okay? So this terrible graph will help you like understanding it. What happens is, for example, we just rolled out an AngularJS application, right? We just did that. And it interacts with a backend which is written in Symfony 2. What happens? Your user on Angular enters its credentials, right? Username and password. Okay, so now the JS app, your frontend, has those credentials. It immediately forwards them to the authentication service. The authentication service actually verifies that those credentials are fine. Okay, there is a user with a username with those username and password. At that point, it generates a token and stores it in a cookie that is going to be available on example.com. Okay, and since let's say all of your services will run on something.example.com, that cookie will be available to all of your services. And the second time, the JS app will just make a call to another service, to the out service or whatever, and we will have that cookie set, and that's going to authenticate the user, right? That's it. It's a pretty basic flow. I mean, it's more complicated as I said it than it actually is. So what's the trick here? You just use a set cookie or whatever function of your own framework. The thing is, the last parameter of the set cookie function is specifies whether we should just set this cookie for HTTP or also or only HTTPS. You say true, it's just going to be a secured cookie. It's only going to run on HTTPS. How do I do all this thing in PHP? Well, there is a library, Namshi Jose. It's very easy. Let's say that the first part is it's what actually happens when you want to authenticate, and the second part is what happens when you want to verify the cookie. So basically, you import the namespace. You said, OK, this is my JWS. This is my token. Set some payload, like the user ID or whatever. That's it. And then you sign it, OK? You sign it with a private key, and then you set it into a cookie. And that's actually a verified signed cookie with a private key, right? So then what happens? You give to all of your services the public key, right? And what they do is just they actually read the cookie, they get the public key, they get the public key, and then they just verify it. The API of this library is super simple. You can use it in really 3 minutes. Thing is, the HTTP authentication was very cool, right? I mean, if you have to use web services, I'm not talking about like for your end users, you know, that username and password box that you have when you want to do HTTP authentication. It's very handy, right? The problem is that it's flawed, okay? You're using modern apps, just use modern technologies for that, okay? And also, there is this is a concern that it's spread through, like when you have like a very high-scale website. All my traffic should go through HTTPS, right? It's gonna suck because it's gonna be slow. Thing is, first of all, it's only the initial handshake that it's gonna like slow down things. But also, it's gonna be slow only if you don't know about stuff like WebP. Do you know WebP, what it is? That's very bad, because if you're serving PNG images from your website right now, you can actually save 30% of the size of those images by using WebP, which is a technology that came out from Google, I think recently, like a few months back, okay? It offers lossless compressions and serves like images that are 30% smaller than PNGs. And if you don't know about Speedy, do you know about Speedy? Do you know anything, what it is? How many of you? Hello? OK, that's fine. If you don't know about Speedy, because Speedy runs only on HTTPS, and it's way faster than HTTP 1.1. Speedy, as I said, is some sort of HTTP on steroids. If you want to know more about it, come to my next talk tomorrow, because that one is going to be cool, not like this one. Then, another point. Embrace messaging. What does this mean? We were talking about events. We were talking about RabbitMQ. Embracing messaging is one of the keys for service-oriented architectures. Don't wait for a client, for a server, to give you back a response. Just notify. Different services in this way can intercept the same notification at the same time, okay? Just connect it to the messaging queue server. If one is down, if one of those services is down, let's say your notification system, there's something like really screwed up with your mail server, and that service is down, all the other ones will still work. You can still sign up the user. You're not going to send him an email, but you can still sign up the user. If you have everything in one application, at a certain point, you will have a mail call, a mail function call, or whatever, that's going to stuck because your mail server is screwed up. That's going to end in an error for the user, right? That's why you want to notify instead. Whenever that service will be up again, it will process that message. Of course, this introduces like some latency, right? Because you notified the RabbitMQ server needs to like do its own things and then dispatch the message to the consumers. But the thing is, it's a matter of like milliseconds. The human bot is actually the bottleneck because the user signs up, it goes back to its Gmail address. Yeah, okay, sorry. It's the only email image that was on Flickr. Seriously. Whatever. So it goes on Gmail, refreshes the page, and gets it. Okay? Same thing for an SMS. You're going to confirm your order. It's going to pick the phone from the pocket. It's going to take some time, some milliseconds. In that time, you've already sent the notification. Be reliable, which means use like a very, very, very widespread tool like RabbitMQ, ZeroMQ. I personally prefer Rabbit. We use Zero, but it has some glitches that we actually didn't like. Rabbit is very, very reliable. And use daemons. Because, of course, you're going to publish messages, right? But who's going to read them? I mean, your mailing server, your notification service, will have to read those messages, right? So you have a daemon running, and listening to messages from RabbitMQ. The cool thing is actually daemons are very easy and are very cool, but that's not what you want to do as a PHP developer, because it's such a hassle to handle daemons. Because what if there is an error, that daemon goes down, who's gonna bring it up again? We don't have daemon managers in PHP. I mean, good daemon managers in PHP. So if a daemon dies, it's gonna go up. Notifications for failures and so on. So you can use other libraries like supervisor or supervise. My suggestion is actually use Python for those things, because it's not built exactly for that thing, but it really helps a lot, because it's one of its natural usages. At the end of the day, it doesn't matter if you talk like some very funny language like COBOL or whatever, because Rabbit makes you talk the same language. You can have a Java chat that sends a notification and a PHP service that processes it. You can have a lot of things in your architecture and use different languages for it, right? The thing is, at that point, you're going to make everything communicate through web services and messages. Say, but I love PHP. Well, but monogamy is so 90. I mean, it's not that given a hammer, everything becomes an A, right? Thing is, let's use the proper technology for what's built for, right? For what it has been built for, right? We don't want to waste. We don't want to generalize. One size has never fit everything. And then we have this saying in Europe. I don't know if it's the same thing here in the US. I mean, it's not always Sunday. It means it's not always a good day when you can rest and relax. Monitor in real time, like use some systems like New Relic that offer real-time monitoring reports and do retrospectives on them. For example, this is the graph that I took from one of our services. We reduced the PHP FPM pools a little bit, and you see the memory usage that's basically has been reduced drastically. Okay, so you can only just do this with this kind of services that offer you these insights. If you're talking about retrospectives, yeah, I mean, Graylog, it's a very good tool to do that. It's basically, because logs become first-class citizens in your architecture, because if something is wrong, you immediately have to check it and see what happened. So tools like Graylog or Logstash, those can help you. And sharpen as much as possible. For example, in Graylog, you can divide logs in streams. Let's say all the logs that have come from this host with this level and whatever needs to go to this stream. So you're just gonna see okay, we for example have a stream that that has logs reports for order exports. So basically, when a customer exports an order, places an order, it goes to our warehouse systems. So if there is a problem, we know where to look and assume things will break. Because things will break, because it's complex, right? All in all, it is actually complex. There's a lot of things into the mix, a lot of new stuff. It's a puzzle with a lot more pieces. It's more things to remember, and that's not an easy task, right? But if you want to do things properly, that's the way to go. With this kind of large-scale project, of course, remember that complex is not complicated. So you might have a complex system that is actually very straightforward. I mean, it's actually complex because it has a lot of things, but it's better. It's not complicated because it's very clear. The flow of things, it's very clear. What do you have in SOA? You have loose coupling, which means that every service is independent. They don't need each other. You're not forced to build stuff based on constraints of another service. So if you have an application written in WordPress and you just want to use WordPress, well, try to build a chat system over there, or any other kind of complex thing, you know? You can use that for a blog or for some other things. It's use those things for what they've been built for. Then you have the freedom of changing an entire service, an entire feature, an entire part of your system without touching the rest. So you know that all the other things are going to work, because I'm not going to touch them. It's a state-of-the-art defense against downtimes and outages. Because, okay, one service goes down, if it's not your main service, because you will always have something that needs to be like more reliable than other services, all the other ones will still continue working, right? And that's called fault tolerance, right? It means that if one of the services is down, all the others will read the notifications, for example, for Rabbit, and do what the hell they have to do. And yeah, of course, a cleaner architecture. I mean, that's probably the most important thing. James was talking about separation of concerns, right? So you say, I gotta do things A here, things B here, and things C here. I'm not gonna mix them all, right? And this makes separation of concern happen at the architectural level, not at the application level. That's how you separate things at the architectural level. And the good news is that this is a perfect ground for advanced tooling. So if you want to use New Relic and stuff like that, or if you want to introduce some new stuff, you can test it very well with a complex architecture like a service-oriented architecture. We're all bored now. I've been like pretty sharp. I said I'm going to introduce it myself at the end. I'm Alex. You can find me on Twitter at the most unfriendly Twitter nickname of the entire Twitter history, _Odino_. I'm currently living in Dubai, working for Namshi, which is a rocket internet venture. It's basically an online retailer, like some kind of Zappos, where I'm vice president for technology. You can find me on odino.org, a lot of bullshit there, and thank you for listening. If you have any questions, keep them for yourself. Especially if your name is James.
I just want to let you know that my Twitter handle also starts with the underscore and it's totally fine.
Oh, really?
Yeah.
Okay. That's some bromance. Okay, if you really have any question, you can ping me now or later. I'm there doing my own business and well, not my own business. I mean, doing my own stuff. If you wanna get in touch, just let me know. Tomorrow I'll have a talk about HTTP 2.0, the new protocol that's gonna come out next year, Speedy, and the history of web protocols.